Yeah, yeah. Actually, speaking of the flu, some people have said that COVID could become like a shot you have to take every year with the flu. Is
Mhm.
that something that you see happening?
Well, so I mean, so far that seems to be what we're heading towards. We already we need to we it looks like we need a couple of shots just to get the immunity for the vaccine to last long enough to get us to next year. Now with flu, there's two things. There's that flu itself evolves or is changing and is escaping potentially the immune response from the previous year. And so it keeps changing. We have to update the vaccine to keep up with that. But it's also that for the flu vaccine itself, generally the immunity that it will induce doesn't last much longer than a year or a couple of years anyway, or at least to high enough levels that it's really well protected. So it requires a booster. So,
That's because the flu will like vary, right? That's because like it'll change enough.
so on the one hand, there is that the flu will vary and will change so that our antibodies will no longer work as well against it. And generally we see, if I recall from this, I haven't worked in flu for a while, but if I recall, it's, maybe an antibody for against your given strain now will ultimately no longer work against the flu that has changed by within 5 years from now. But there's that. But there's also that the vaccine itself induces immunity that doesn't last forever compared to other certain vaccines for other viruses, for example. So with the vaccines we have now for coronavirus, it seems that these vaccines do not induce a long lasting immunity. And we probably will have to get a booster anyway, X number of months or years from now to reactivate the immunity. But then what we don't know is, will the virus itself also evolve and mutate to no longer be recognized by those antibodies? And so we would have to update it as well. There's two reasons for which we might have to update and do get vaccinated more than once. Compared to, let's say, something like polio virus, which you can be vaccinated for once for your entire life if it's the
Yeah.
attenuated vaccine, and your antibodies will always recognize it because that virus doesn't change. And
Okay. And then actually, so just for people who like don't know as much about like specific viruses, what actually is it in like the Zika virus compared to COVID that like has the vaccines for Zika work for it just once? Or sorry, you said
polio, polio,
yeah,
polio virus.
polio. So like what is it about the polio virus versus COVID that prevents polio from changing to evade like the vaccines?
So in that case, I mean, it's you'd have to answer this question virus by virus, vaccine by vaccine, because they're all different. They're all different combinations. But in this particular case, polio virus is completely well adapted. It's been perfectly adapted to humans. It is strictly human, so to speak. It's a virus that belongs to us. It's been with us for thousands of years, but it's a proteinaceous virus. It's only made of proteins. It's ultimately structurally, it's very rigid, and it has to, the way its actual structure has to be a certain way and cannot vary. So our immune response will recognize part of that structure, which is essential to it being able to infect our cells. And it just can't change that in many other ways without messing up the rest of the structure of the virus and falling apart. So it just happens to be its weakness is that it can't change that. Whereas the immune response that is directed towards coronavirus is not against a protein that is so rigid in its structure and how it fits with other proteins. And so ultimately there's a little more flexibility there where that virus can change how it looks to evade the immune response. That's in this particular case, right? But it's also the kind of vaccine. For the polio, I was referring to a live attenuated vaccine that we used to give. We don't even give this anymore, but we used to give a sugar cube basically, and it was a live virus. So it actually was it no longer caused the disease, but it
Right.
replicated in us. And when you have a live replicating vaccine, the immune response is much, much stronger. And it's more long lasting because it's seeing an actual real infection. Whereas for the coronavirus vaccines, it's just a protein, for example. And so it's not
Right.
going to necessarily give a long lasting immune response.